Hi, welcome to ReThynk AI Quest, where we use artificial intelligence to solve some of the biggest problems and challenges of the world with the help of artificial intelligence. So far in this quest, we have focused on two topics. One is stampede prevention using artificial intelligence, and second, preventing bridge collapse using artificial intelligence. These two lectures has been covered. These two quests has been covered and they are available on this YouTube channel. So if you have not watched them yet, please watch them. And today's topic is really special. But before we move to the today's topic, if you are new to ReThynk AI, then please consider subscribing. Don't forget to press the bell icon. And most importantly, if you knew someone who is working in government departments or different ministries, then share these videos with them. It can provide them necessary, essential knowledge to have, comprehensive solutions about these problems. So let's dive into today's topic. And today's topic is urban flooding. Due to climate change, urban flooding has become a common topic and a common phenomenon around the world in most of the time in metro cities. So let's dive into this topic and focus on finding the solution. This is the third quest of ReThynk AI, where we are using artificial intelligence to make this world a better place, or we are using artificial intelligence to make this world a smarter place. This is a beautiful diagram to show you the exact problem, what we are facing in this world. This image has been taken from worldbank.org. This is about the urban, global trend. So this beautiful organization tracked urban flood exposure since 1985. 1985, almost 40 years. And this is the representation or the image of one from Vietnam. If we look at the left-hand side, this was the image of 2002, and second image is from 2021. So the gap is 19 years. But if we see in 19 years, most of the area of this, nearby river or floodplain area has been covered by the settlements. People have started living very near to the river area. Okay, they have basically covered the floodplain area. So this is not just in Vietnam, but it's happening around the world. Most of the settlement or people start basically living near the river areas, and that's become one of the major reason of urban flooding. So there are people who says that the flood has came in our city. Then the answer is then it's wrong. Actually, we have started living very near to the river. The river has not crossed our path. We have basically crossed the path of the river in our race of becoming becoming profitable, economical, or capturing everything. We have forgotten that this is their planet as well. So let's talk about today's objective. Today's objective is to build an AI-powered early warning and real-time flood monitoring system using sensor networks, citizen input, weather data, and infrastructure simulations to reduce damage and protect lives. This image is really wonderful. This image show a lot. So out of right now we have talked about just one problem, which is in riverside settlement. Okay, let's talk about more problems. Every monsoon in Indian cities mostly, but this is not limited to Indian cities. It's true for all the major cities around the world. Indian cities come to a standstill. Roads turn into rivers, drain overflows, and people lose lives, homes, and critical time. Why? Because there are a couple of reasons. One is poor drainage design. Next is zero data-driven infrastructure planning. no real-time flood response visibility, and reliance on manual crisis management. However, let me tell you, this is not just one image. This image has different interpretation as well. Those people who have started, getting settled near the river area, maybe they have not taken the infrastructure planning into consideration. This is very necessary. So the problem is not just urban flooding, the problem is much deeper. This is a stock image. This stock image has been taken to show you one reference problem. If we look at this particular image, right, yes, there is water on the highways, okay, on roads. Okay, maybe there is no flood situation, but still this image represents many more problems. One, the loss to our vehicles. We are driving our vehicles in the flooded street. There is definitely damage to our vehicle. Second, loss of our critical times. Time is the most valuable asset. Productivity loss and chances of getting different kind of diseases is also very high. So this is not just the problem of urban flooding where, just flood comes and in our streets or roads, but it's more than that. So what are the consequences of inaction? Loss of lives, in many cases, property and mobility. Then emergency systems overstressed, drainage plans are outdated by decades, and it's happening continuously because the population density is rising continuously in major metro cities. People are migrating from village to metro cities or urban areas. We had different examples like Bangalore, Mumbai, and Chennai floods, and often these floods repeat. Why they repeat? Because let's take this is the urban area, right? And everything is congested here. From people have taken let's say this is just a river path, okay? And we have occupied it here, and continuously everywhere. So what is happening? We have just occupied the river path. So whenever there is excess of rain, there is no river plain area or flood plain area. So automatically this water comes on our streets or highways. And the major reason is there is continuous migration from villages to urban areas. So population density is rising in urban cities, metro cities continuously. And that's the real challenge for us. So what is my thought leadership about it? AI thought leadership, basically, you can say my thought leadership or a thought leadership by combining some of my experiences and my perception about artificial intelligence. When cities flood, it's not just water that fills the street, it's the helplessness. People trapped in buses, homes, submerged, lives put on pause, and every year we call it unexpected. Even though it happens again and again, the truth is urban flooding is no longer a climate issue alone. It's a failure of planning, prediction, and preparedness. Okay, but it doesn't have to be this way. We are living in the age of artificial intelligence, and we can't put everything on the name of climate issue. No, it's more than that. We live in an area where satellites can see clouds forming hours in advance. Sensors can detect rising water level in real time, and AI can simulate how every drop of rain will move through our cities. The technology exists. What we need now is that the will to implement it, not for recognition, but for resilience. I always believe that we should stop working for recognition. And media representation or, getting awards or whatever, like these are the byproduct of the great work we are doing for the society. These should be getting recognition, should not be the central aim of your projects. Okay, it's not about smarter tech, it's about safer lives. I am not thinking from the perspective of using artificial intelligence. I am thinking from the perspective of, making people's life safe. What if, there is a flooded street and the main hole is open and someone fall in that main hole? It's a critical problem. Okay. When we talk about smart cities, let's make sure we are not just talking about apps and traffic lights. Let's build cities that don't drown their people. Let's act before the flood comes. So basically, it's all about using the artificial intelligence to ensure that we have better planning and prediction, and we can take decision wisely. So what is the vision statement for this particular quest? To make Indian cities flood resilient through real-time monitoring, predictive intelligence, and citizen collaboration. Plan smarter, act faster, and most importantly, save lives. So now let's talk about 8 phases. We are going to talk about every particular aspect of urban flooding, from the problem statement to the solution statement. First, city flood risk intelligence platform. Okay, urban AI simulation engine, how we can solve it. Now let's talk about that. First, we can create a digital twin of the city using drainage map, rainfall zones, slope and elevation, past flood data. Basically, let's create a digital twin city where we have the digital replica of our city, where we have everything from the drainage system to rainfall zones to slope and elevation and past flood data. We have everything that we can use in our favor. Second, infrastructure vulnerability mapping. Why? There are weak bridges, or maybe the bridges which has not been repaired for quite a long time, low-lying areas, blocked drains, or areas with waterlogging history, continuous waterlogging history, or poorly planned construction in zones. If we have all this data, then this data will become a critical part in our planning. First step is doing the digital mapping. Second step is infrastructure mapping. So why it's so important? Let's imagine this scenario, simulate this scenario. What if it rains 100 millimeter in 3 hours in area X? So let's say we are taking the example of Delhi. What if it rains 100 millimeter, 100 mm in 3 hours in South Delhi, or in West Delhi, or in East Delhi, or in Central Delhi? So when we are going to prepare these mapping and digital simulations, then we can come across all these scenarios. Okay, until we are going to focus on these scenarios, we will not have the complete solutions. So if you are government employees, let me ask you this question, or if you are saying you are very wise, what if it rains 100 mm in 3 hours in your area? How are you going to solve it? How are you going to tackle it if you don't have this particular information? So nothing is random here. Everything has been well planned. Second phase, real-time flood prediction and alerts. So point number 3, IoT rain and drain sensors installed at key junctions and choke points. There are, you can install rains and draining sensors where we can get the real-time data. Remember, artificial intelligence is all about data monitoring. What we will get out of it: rainfall intensity, drain water level, and overflow status. This will become a crucial point. Then fourth, AI weather plus drain analysis. Here we can combine IMD forecast, satellite rainfall images, and local drain sensor data. That can help us in predicting street-wise flood probability 2 to 3 hours in advance. And if we have already made our prediction 2 to 3 hours in advance, then we can distribute the data to the necessary audience, or those people who are living in that particular area, including adding these things on Google Map as well, so that people who are traveling, who are about to travel from that particular area, they can avoid it, and we can show them the alternate route. Phase number 3, this is one of the best presentation I'm making: community and powered data alerts. So we can build an app as well for citizens with, let's say, Urban Guard app, or any name. like Indian app. Okay, real-time updates on safe route. Okay, first of all, citizens, with the help of this app, either you are going to add this on Google or you can have your own app as well. It can provide safe routes. It can provide flooded areas. It can provide public transport delays. Okay, people can get the real-time data. Plus, we as an authority can allow them to submit photos or videos from their nearby area or the whatever the information they have. It's like crowdsourced validation. We have our data on the basis of our sensors, and people are going to drop their own photos or videos as well. They can submit this information, and it will become a pool of public-private coordination or crowdsources data. So how it will help? Live flood dashboard for authorities, central command system for municipal and disaster teams. Okay, it will create map view of the city, water depth in each zone, red zone like high risk, predictive alerts plus recommended actions. Okay, so no, so far we have created a complete system where people can participate, government can see what is happening, and they can see the exact situation of every particular area. Phase 4, smart response protocol. Okay, then here we can use AI-based evacuation suggestion. Okay, suggest which route to close or reroute or push emergency evacuation message in case, let's say, there is a bus which is going through a tunnel and the tunnel is flooded and now they are stuck there. In that case, we can push for emergency evacuation. 8th, infrastructure action triggers, where we can automatically alert if the situation is really critical or in red level. Then we can have pump activation, sandbag. We can send the sandbag teams to divert the water route, or we can send the traffic control unit. However, this project is not limited to this particular situation only. In future, you can have different application of this app as well, like emergency situation. In emergency situation, you can reroute the entire traffic in flood and in winter areas when there is huge fog or smoke. In that time, you can again use this app to provide the real-time data or to see the real-time data around the locality or your traveling path. This app is not limited to urban flooding. This app is beyond imagination. Oh, next, what if we simulate different scenarios? What if 1,000 vehicles are stuck in traffic for 8 hours continuously? Listen, let me tell you something. If you are traveling in free time with your better half is sitting around and sitting beside, and then you are traveling with some light music and it's light rain, it feels awesome. But if you stuck in the traffic for 8 hours and without any movement, when the rain is everywhere, the water is everywhere, it's literally choking the roads, then it will not be a romantic ride. It will be a chaos. It will be a challenge. So what if 1,000 vehicles are stuck in traffic, or 100 vehicles are stuck, or 200 vehicles are stuck? Then what will be our response? And what if we have to evacuate people in a short time? What if there are people who are stuck and we have to evacuate them? So that's the situation. Now let's look into how to implement it. So far we have discussed the theoretical part. Now let's come to the implementation part. Let's create this digital twin city. This is not the replica of any particular city. This is an example. Let's say this is the digital twin of a particular city. Here we can see everything, like how the water is, the depth, the height of different regions, the drainage system. Okay, and we can see the area which has repeated flood history. So after creating a digital twin, we can focus on predictive simulations that what will be different situations. Then we can implement IoT powered sensors at different locations on the basis of our scenario. Then we can create live risk dashboard for people. Then we can have AI based evacuation, not only human beings, but AI is going to work together and they are going to find the solution. And then citizen powered flood reporting, so that in case there is an emergency, they can, trigger a ticket and they can get the response. This is again, let's say we are making Urban Guard AI. So it will be predictive simulation using digital twins, IoT powered sensors, live risk dashboard, AI-based evacuation, citizen powered flood app. So basically, it will create a complete, comprehensive solution for people. Let's say again, this is just the 360-degree view of the solution. Now let's see the flowchart. Flowchart is first step is create the digital city twin, where actually you are going to create your data. Then after creating the digital twin city, you can analyze the different choke points, the red points, the emergency pointers, and there we can have our drain sensors. Next step, integrate the weather report and flood prediction report from IMD. Next, fourth step, crowdsourcing. Remember, if you are going to have people on every particular location or employees in every particular location, then it will be a very costly project. So allow crowdsourced data where people are going to become, people are also going to engage and they are also going to become the part of it. And then push alert, trigger action if the crowdsourced data or your own brain data says things are getting out of hand. And this is the step-by-step explanation of our workflow. Build digital city, install rain brain sensor, integrate weathers, launch mobile app, feed crowdsourced data, push alerts. So let's see the different representation of this workflow diagram in the way of foundational work and explanatory work. Foundational work. First, we need a city data layer, then a digital twin simulation, and third is vulnerability mapping. This is the fundamental workflow. In engineering, I did something amazing when I was doing my engineering. In every answer, basically, I focused on 2 points. One, the basic workflow diagram, and then the explanatory workflow diagram. And I don't know why, but in every university exams, those who were checkers, they literally liked that way because it was reflecting in marks. Okay, so this is the foundational diagram, and it's always good to have the explanatory workflow. Remember, engineering is not just about opinions. Engineering is about connecting all the fibers, all the pointers. Okay, engineering is really vast if you are doing it for passion. However, if you are doing engineering for just for the sake of getting a job, then it's not the fun. Then how it's going to reflect here. IoT-based sensor layer. After creating this, we are going to have IoT-based sensor layers, then AI prediction engines. Okay, then flood risk dashboard. IoT sensors are going to give the data, AI is going to work on the data. Then there are flood risk dashboard. From the flood risk dashboard, we can have evacuation triggers or infrastructure response team. Most importantly, AI prediction also take the data from crowdsource. Okay, here people are going to be the part of the crowdsource, and there will be real-time alert options and communications option for people as well. This is the first phase. This is the foundational phase. This is the advanced level. This is how your dashboard is going to look. You can create any type of dashboard basically on the basis of your requirement, but I think the right dashboard is like this. Here you have city map, live flood zones. Level A, high risk zone, zone A, high risk, zone B, medium risk, zone C, safer area. Basically, green area is safer. The orange area is where there is, we can have yellow alert. or the red zone where we have emergency and we need immediate evacuation. Then live status and alerts like zone C, where is the safer zone, all clear. Zone B, drains overflowing. Then we can have deployments of pump. However, if we are reaching to zone A, where water level is above 1.5 meters, we need immediate evacuation of people. Here we can send alerts to authorities, we can activate pumps, we can close different roads, or we can see the reports. And if you want to, and then you can have a separate column for crowd sources information as well. Beside that, if you want to have more expansion, you can have rain prediction meters or water level predictors that are showing side by side, okay, or public data, or notice for public, or note for public. Okay, that's how you can create your own dashboard. And one of the most important things which I have found in after my years of studies, that in not only in India, let's take the example of India only. Indian society, Indian municipalities or authorities are working around the countries to upgrade the cities, right? They are coming up with new highways. They are doing repair works. They are, they are working on sewage pipelines. So what happens? Often they go and they dig different routes of roads to have, water transportation line, sewage line, or electricity line. Okay, so in that case, what they can do, they can also update their data. Maybe let's say, let's take this. Let's say there is some form of construction work from A to B, right? So authorities also can update the information. So it will become, Google is not going to update all this information immediately. Okay, Google works on the basis of different concept, but here authorities can update that this is, if from A to B, we are having the construction and this road is closed. So the alternate route is, let's say this is the alternate route. Okay, in that case, people are going to be safe and there will be no, you can say, no traffic on the blocked road. Okay, people have a better experience, we can say that. Okay, now let's go to the next part. I hope you have liked this. What I like about this is, what is my favorite part is creating the dashboard mockup. Okay, that how we can integrate entire data at one particular place to make it, to create the optimum solution for the entire society. What is technology summary table? Let's have the summary. Okay, this is for those who are from tech background, engineering background. They are going to understand the importance of it. These are 6 layers: sensors layer, rain goes, drain sensors, smart manholes, AI models, flood predictions, load estimations, route optimization, then city risk zone via GIS, then cloud and backend, IMD API, satellite data, AWS or Azure, whatever cloud sourcing you want to use. Then citizen interface, Urban Guard app, or authority tools like flood risk dashboard, automated response planning. And if you are working on this idea, I would like to know more about your project. Next, what is community powered impact? Remember, citizens are the the soldier of the society. A responsible citizen is always a soldier for the society, always a worker for the society. App enables citizens to report flood zones, view safe routes, receive live advisories so that they can have, if there is no necessary traveling, no emergency, they can avoid it. Or if there is necessary or emergency, or they are already on the route, they can have different route. It will build trust and shared ownership between people and authorities. And remember, one of the best thing in democracy is having the proper coordination between citizen and authorities. What is response automation? AI triggers pump activation, barricade placement, alternate traffic routing, smart escalation to NDRF, local disaster team when thresholds are breached. So what is implementation plan? This is the implementation plan. For 1 2 week, you need cities. You need time to create city digital twin creation. Second, sensor deployment in the third week. Sensor deployment in the fourth week. AI model integration. Fifth week, app plus dashboard beta launch. Sixth to seventh week, we can have dry run during pre-monsoon rainy season. And what are some of the places to implement or to start? Then these are the options. Because of high population density, flood-prone area, urban complexity, Mumbai, Bangalore, Chennai, Guwahati. Okay, these are the areas where people have shown much responsibilities, or they have taken they have worked in a way that represent the responsible citizen. So that's the right implementation plan. What will be the impact of this? It will make more resilient, responsive cities, real-time visibility for all stakeholders, data-informed infrastructure updates, and 60–70% reduction in flood damage and delays. So what is my final message? Floods are not just a natural disaster, they are a failure to act in time. Let us choose foresight over our target. So I hope this you have liked the third quest, which is using artificial intelligence to make the smart cities. Okay, this lecture has been presented by me, founder director of ReThynk AI, researcher, keynote speaker, and author. And this presentation has been made by ReThynk AI, researched and made by ReThynk AI. These slides have been made by Vista Data. They are our permanent marketing partner. If you have any question, you can reach out in the comment section, or you can reach out to these particular details. Till then, take care of yourself. If you have any information, you can share with us, and have a great weekend. Thank you so much.